Hey, this is limits, the beginning of calculus. Here we go. So before we talk about a limit and how that's the beginning of calculus, can you describe the end behavior here using math statements? Do you remember how to do that? So when I look here, I know the right end is going down. So mathematically, I would write this as x approaches infinity, the function approaches negative infinity. That says the right end goes down. And the second part, the left, as x approaches negative infinity, well, that side goes up. So the right end goes down, the left end goes up. That's describing this end and this end. Let's try again. Now the right end behavior is going to a number, and that number is 1. So as x approaches infinity, the function is approaching, in this case it's approaching 1. As x approaches negative infinity, so the left is also approaching 1, but from the left. So we did end behavior statements to help us understand how to understand the concept of a limit. So what is a limit? And it's the y value as x approaches a number. And so the idea of approaching rather than equals is a big concept in calculus. So what's the y value as x approaches a certain number? So what's the y value it's approaching rather than what it's equal to? So limit notation. So LIM represents limit. And we would say as x approaches a certain number, we'll call that c. And then whatever that value is it's approaching, that would be the, and usually sometimes use the word that, but the big idea is this is the y value that's approaching as this is the x value approaching. Let's try this concept of a limit notation describing the end behavior. So I want to know what the end behavior here, the right end and the left end. So if I want to know the right end, we're going to call it the limit as x approaches infinity of this function. We'll call that function f at x. And what's the answer? Well, the right end is going to negative infinity. The other end we're going to write as a limit as x approaches infinity, again of that same function, and the left end's also going down, so it's also going to negative infinity. Number 4, just practicing limit notation. The limit as x approaches infinity of that function. The right end is going up. The limit as x approaches negative infinity. Oops, this one should have said negative infinity. That one's negative. This one's also negative. And the left end is going down. Here, the limit as x approaches infinity, that's the right end of the function, is equal to infinity. So it's similar to what we've been writing. We're using a new notation, but a similar way to describe it. And where's the left end? The left end's also going to infinity. Number 6 and 7. So where's the right end going? So the limit as x approaches infinity of f at x. The right end is going up. The limit as x approaches negative infinity. The left end here is going down. Number 7. Notice how this flattens out to a number. That'd be 1, 2, 3, 4. I think it's 4, right? Negative 4. So the limit as x approaches infinity of the function, it's approaching negative 4. The limit as x approaches negative infinity, the left end, it's going up to infinity. The right end of the function is approaching 0. The left end of the function is also approaching 0. So both the left and the right end are approaching 0. So a new way to describe end behavior using limits. All right. So what if c is a certain value? If c is a certain value, then the limit is the value which x is approaching from either side of c. It's important to understand that a limit is not what happens at c, but rather what is happening to the function near or close c, or as it's approaching. And this is going to bring a calculus understanding of continuity, if something's continuous. So the value of the limit and the value of the function equal the same number, then it's a continuous function. All right, let's look at this. So here's an example. The limit as x approaches 2 of this function. And I want you to complete the table and then verify with the graph. So if you plug in these values using a calculator, so I'll use a calculator and plug these values in. So let me clear what I have right now. And so I'm going to write down, I'm going to evaluate this. So what I'm evaluating is x subtract 8 over x squared plus 4. And then with this calculator to evaluate, we're going to go control and equals. And then after that, there's a vertical line that we're going to select. So that allows us to evaluate. And then we're going to evaluate at x equals 1.997. And we get the answer negative 0.752. Plug that in. Then I'm going to just change that number to 1.998. So I'm going to do this and then go back and change that to 1.998. So now it's negative 0.751. I'm going to do it again for 1.99. And I get negative 0.751 again. I'm going to do the same work at 2.011 and like from the other side as it approaches 2 from the other side. So 2.003. That's negative 0.749. I'm going to do it again. That's negative 0.749. Then do it again, 2.001. Negative 0.750 if you round it. And now the question is, if I look from the left and I look from the right, what is it getting closer and closer and closer and closer to? So if I round it, you can tell the left side and the right side, it's getting kind of closer to negative 0.75 if I was going to look at it, right? And so from the left and from the right, it's getting closer and closer to that answer. And they agree, both the left and the right are agreeing it's getting closer to that answer. So estimate each limit using a table or using a graph. Now, so it says helpful to change your table settings to like 0.001. Let's look at that. delete this. So let's say I put in the function it's asking for, right? Which is 3x subtract 2. And there's that function. If I go to menu and I go to table, I can change if I go menu and table, I can edit the table settings so that the step they're talking about, and for this one, if it's approaching 4, then let's start with 4 right here. And then they said change the table settings to 0.001. Here, let's go menu, table. All right, so, and notice that it will also give you the same answer as a decimal as you highlight over it. So if I look at the table here, by looking at the table, if I come in here from the left or from the right, you can see the answer is 10.015, 10.012, 10. And it goes from there. Oops. What happened? Oops. Sure, I got my table again. All right, let's do a table again. Menu and table. And if I go menu again, you can change the attributes of it. So if I edit table settings, I can start at 4, and we have 0.001. And if I go from this side, you can see from the other side, the answer is approaching. Now, here's a good thing that you need to know about limits, is if this is continuous at 4, that means there's no breaks, no jumps, none of that. Then this is approaching the same answer. You can simply substitute in to find the limit. So this is from the left approaching. As you look at the answers is getting closer to 10. And then from the left, it's getting closer to 10. And from the right, it's getting closer to 10. And exactly at 4, the answer is 10. So one thing we learned about evaluating limits, if the function is continuous, then we can just evaluate at the number it's approaching. So 3x subtract 2, there's no breaks, no jumps. The domain has no restriction. It's continuous. Plug in 4 for x, and you get your answer. So we're going to do that and use that understanding. Here, this is a parabola. There are no restrictions. How would I know if there's a restriction? So if there's a fraction, and in the denominator, some value made it 0. There's a whole, something removable. Square root, right? We have to be careful to make sure that it's what's there. So for this situation, at -1, this is continuous everywhere. So I can just evaluate at -1 to get the answer. Again, these are all polynomials. These are positive whole exponents, nothing, no restrictions. And so you can just evaluate at the number to find the value of the limit. Now this one we need to be careful about. So at -3, when it's approaching, this will be helpful to have a calculator because this is not continuous at -3. What happens when you substitute -3 into this function? -3 squared subtract 9 The answer is 0. It's undefined there. There's a break. It is not continuous at -3. So we're going to use a table to help us find the limit. So this one's helpful to have a table to find the limit compared to what we had before. So let me, oops, not what I meant here. Let me, first of all, let me remove the table to begin with. And then I'm going to retype it. So I'm going to press Tab, and then I'm going to remove this, what we had before. And I'm going to put in what our function is, which is go Control and divide. It's a fraction. And we have x cubed plus 27. And in the denominator, we have x squared subtract 9. All right, so there's our function. And I want to know what the limit is as x approaches a -3. So we're going to go Menu and Table. Again, I'm going to go Menu. Notice at 3 and at -3, it's undefined. So I'm going to go Menu, Table. I'm going to edit the table settings. And then I want to know, like, starting at -3 and then 0.001, I want to know before and after, what is it approaching? So if I look before, look at the values there, -4.49. And if I look here, it's better to start low and move your way up here, but I can see -4.49, -4.49. In fact, it rounds to -4.5 and -4.5. It's getting closer to that answer. Then once I get there, it's undefined. On the other side, I'm going to do the same thing. See, I see -4.5, -4.5, -4.5, -4.5. It's getting closer to that. Then once we get there, the answer is undefined. So from both sides, the answer is getting closer to -4.5. And when I get there, it's undefined. So the value of the limit exists. And the answer is -4.5. But the actual function doesn't exist there. So the limit exists, but when you plug in -3, the function value does not exist. That's one of those definitions of discontinuity. So something can be discontinuous, the limit can exist, but the value of the function doesn't exist. All right, number 13. Is it continuous at 4? So if I plug 4 into the denominator, it's 0, it's undefined. So I'm going to use my calculator again to see if I can find a limit. So let's go back here. I'm going to press Tab, and I'm going to get rid of this one. And I'm going to put in the next function. So it's Control Divide. I'm going to put in x squared subtract x subtract 12. The denominator, x subtract 4. And then I'm going to change the menu, the table. Oops. So there's table. All right, let's start again from scratch here. So menu, table, split screen, and then go menu again, and then go table, and then edit it. And then we want to know right when what? As it approaches 4. So we're going to put in 4, and again we're going to go 0.001, and I just want to know, I know at 4 it's undefined. So you can see it's undefined. And so I'm going to, underneath, if I get closer, 7.003, 7.002, 7.001, what answer is it getting closer to? 7. And on the other side, same thing, look at the answers, 6.99, 6.997, 6.998, 6.999. So again, it's approaching what answer from both sides? And the answer is 7, and when you get there, there's no value. So the limit exists, and this answer is 7. But the function value is undefined if you just plugged in 4. So we're using a table to help us find a limit. Here again, if you plug in 0 for x, it's undefined in the denominator. So we're going to use a table to help us understand what the value of the limit is. So I'm going to go tab. Oh. All right. So I'm first going to remove the table. I'm going to put in the function I want. So I'm going to delete this. I'm going to go control divide, and our function is x squared plus 2x. And then in the denominator is x cubed subtract 4x squared what do we got? Plus 4x. All right. I'm going to do menu and a table. Split screen. I'm going to go menu, and I'm going to go table, and then edit the table settings. So I want to start at, what is it approaching? 0. So it is. And then 0.001. So as I do a table here, from one direction, 0.497, 0.498, so 0.5, 0.5, undefined, and on the other side, it's getting closer to 0.5 the closer I get to 0, coming from the other direction. So both sides agree that the answer that it's approaching is 0.5. All right, the limit as x approaches 1 of this. Again, at 1, the square root of 1 take away 1 is 0. It's undefined. It's not continuous. So we'll use a calculator to help us do a table to understand this better. So sometimes I got to remove the table, then I'm going to change what the function is. So press tab, and then if I remove this, you can see what we're doing. Now I wonder, I could also do, you know what I'm going to try to do? Let me try this. Move it over here. I wonder, let's hope this works. So if I did Desmos, let's just say. So let's say you didn't have that calculator. If you had Desmos here, and if I wanted to do this, you could x1 and x2. So if I defined it this way, y equals, and it's x subtract 1, and then in the denominator is the square root of x subtract 1. And if I did a table here this way, so if I called this x and this y, I think it would work. So if I plugged in numbers around it, so like if I plugged in 2, will it give me the answer? Oh, it doesn't like it. So if I said x1 see if I do it this way, will it give me the answer? It's not going to give me the answer. Okay, so let me just call this y1. So for some reason it doesn't like that. So what's wrong here? So I'm trying to figure out why it doesn't necessarily like to take a table. X1 and Y can't be defined in terms of each other. So I'm trying to figure out in terms of the table here. I don't know. I'm going to try. again a different way. Why not? And see what happens here. So again, it's x subtract 1, and this is the square root of x subtract 1. You can see the graph here. So if I call this x and this f at x, oh look, it liked that. So why not do it that way? Okay, so live and learn. I want to know what the value is as it gets closer to 1. So if I go 0.997, 997, 0.998, 0.999, you can see what answer is getting closer to. It's getting closer to 2. If I put in 0, if I put in 1, I mean, it's undefined at 1. Now from the other side, if I put in 1.003 or 1. In fact, here, I'll go this direction here. I'll do this. So 1.001, 1.002, 1.003. From this as well, you can see the y value is getting closer and closer to 2 from both sides. But when it gets there, the answer is undefined. So the limit for this one, the answer is 2 using a table. For 16, an exponential is continuous. So I can plug in -2 into a continuous function to evaluate a limit. That's 1/4 plus 3. So that's 3 1/4, or 3.25. Here, at +3, if I plug in, it's undefined in the denominator. So this one here is not continuous at 3. So I'm going to use a table. So I'll come back to this. So the equation, again, is x squared subtract 5x plus 6. The denominator is x squared subtract 7x plus 12. So we're trying to find the limit as x approaches 3. So if I use 3 right here, it's undefined. So if I use 2.997, 2.9982, and on this side if I say 3, look at the answers. Does it approach the same answer from both directions? So getting closer to 3, the answer is getting closer to -1. From the other side, the answer is also getting closer to -1. So both sides agree. As I'm getting closer to 3, the answer is getting closer to -1, and that's the limit. So the limit as x approaches 3, the answer is -1. So a limit can fail to exist. If you've ever watched the movie Mean Girls, at the end of the movie, she's in calculus, and the question is what the value of a limit is at the end of the movie. And the answer is does not exist, wins the whole thing for her high school, if you remember. So a limit that may not exist. So it can fail to exist under any of the following conditions. The function might contain a jump. That's a discontinuity. And that means the right and the left don't agree at what the value is. So a jump in the graph. An asymptote would be it as well. And that means one end goes to infinity and the other end goes to -infinity. They don't agree. Or if it oscillates, if it goes up and down and it never approaches a number because it keeps going up and down, up and down, up and down. So we're going to estimate each limit if it exists. So let's look here. We're going to do it algebraically. So we're going to see if it's continuous or not and then evaluate it using it. So at -1, so I'm going to write this as if I look at -1 to the top piece, -1 squared is 1 plus 1 is 2. And -1 subtract 2. So this gives me the answer of 2. If I plug -1 into the bottom, it gives me the answer -3. These numbers are not the same. There's a jump. So this does not exist. And it doesn't exist because there's a jump at -1. For one answer is 2 and the other answer is -3, it creates a jump in the graph. All right, let's look at it again. For this one, if you plug 2 into the top, 4 times 2 is 8, take away 2 is 6. Plug 2 into the bottom, 2 squared plus 2 is also 6. So this is from the left, this is from the right. They both agree what the answer is. So the answer to this is 6, because there's an agreement to the answer. Here they disagree, so the limit doesn't exist. For number 20, if I substitute in, it's continuous, so all you do is substitute in 3, and it's continuous, and the answer is -7/6. For here at +1, it's 0, and it's an asymptote, so it does not exist. If I plug +1 in here for 22, this one creates a hole in the graph. So if I looked at number 22, if I wanted to evaluate that limit, I could evaluate that limit off a graph to understand and see what it is. So let's say I do this with a graph. So I'm going to type in x cubed subtract x, and in the denominator -3x squared plus 12x, take away 9. And then if I want to understand the answer, it says as it approaches 3. So if I follow this graph along, as it approaches 3, what's happening? So I'm trying to get closer and closer to 3 here, following the graph. So as I get closer and closer to 3, wow, it's getting up there. I'm trying to see what does it approach. So it's getting closer and closer, so you can see what's happening. Oh, I'm using the wrong number. No wonder it's happening there. It says x approaches 1, not 3. I was looking at the wrong question there. So let me zoom in again here. Thinking, man, that doesn't seem right. All right, so let's get back here. So as x approaches 1, so here we are, as x approaches 1. Once we get to 1, you can see that the answer is 1/3. So see how the answer is 0.333 when we get there. Oh, and 0.336. But can you see it's very close in terms of what's happening in terms of 0.3. So x cubed subtract x -3. I just typed it in wrong. That was the problem. So let's do it correctly. Oops. So I like x cubed subtract x, but then the denominator should have been 4x squared. My goodness, not my finest moment here. So 4x squared plus 12x, take away 16. Let's see if I can do this right. So x cubed subtract x, 4x squared plus 12x, take away 16. As x approaches 1, and notice as x approaches 1, what's the answer? And the y value is 0.1. If I just said what's f at 1, the answer would be undefined. But if I use the graph and understand it, at 1, the answer is 0.1 if you round it. Right there. Oops. There. Long way to get there, right? 23. If I plug -1 in here, it's undefined, it's not continuous. Let's use that one. I can do better. Let's see if I could do this one better. I know I can. Take my time, make sure I type it in correctly. And then we'll see. So f at x equals, take my time, type it in correctly. F at x equals, and again, make sure I type it in right, x squared plus 3x, take away plus 2. And then I need the absolute value bar, so I'm going to do that, x plus 1. And so I want to know what the value is at -1. And notice at -1 there's a jump. So on this side and on this side, in terms of it, there's a jump in the graph at -1. So the right is approaching right here. It's really approaching +1. And on the left it's approaching -1, but there's a jump right there, so therefore it doesn't exist because of the jump. If I plug 3 in, again, it's undefined. It's not continuous. So let's use a graph to be able to understand it. So 9 subtract x squared. And then in the denominator would be x subtract 3. So as x approaches 3, what's happening? So as x is approaching 3, oops, I passed it. So as x is approaching 3, notice it is undefined at 3, but the left says it's getting closer to what answer? -6. And on the other side, it's getting closer to -6. So right there where the hole is, what's the y coordinate there that it's approaching? And the answer is -6, using a graph. All right, I want you to type that in to Desmos, look at the graph, and see what's happening at -4. And what I want you to notice is there's a jump in the graph, and that's why it doesn't exist. For number 26, here's a trigonometric one of 1 over x. And again, what I want you to notice at 0, let's do this one because it's going to oscillate. So it's kind of a fun looking one. So let's do that for fun. So the cosine of 1 over x. So if I look to see what's happening around 0, what's happening around 0 is that you can see that it's going up and down, up and down, up and down, up and down, and it's not approaching a y value as it's getting closer to 0. It almost looks like an accordion or something like that going up and down. So there's another reason why a limit wouldn't exist at 0, because it's not approaching a number. For number 27, the value of sine, a sine is a continuous function. So the value here, you plug in 0 for sine and use your calculator, or remember your unit circle. So the value of sine at 0 is 0. So it's really just 1/2 times -pi/2. So for 27, so this is 0, so this is really -pi/4. So again, cosine is a continuous function here. There's nothing that would make it undefined. 0 here would make this undefined. That's why it oscillates like that. So the limit as x approaches negative, and really there should be parentheses around here. So you can see it's negative cosine squared x. So again, we're going to substitute pi/3 in because it's continuous. You can use a calculator. Should be like that. The value of cosine at pi/3 is 1/2. And then 1/2, so the whole thing is -1/4. 29. Oh, this one's going to be, again, see how it goes pi over x? So this is one that oscillates again around 0, so that's why it doesn't exist, because it oscillates up and down. Here, at pi over 2 for tangent, if you graphed it, there's an asymptote at pi over 2. So that's why this doesn't exist, because of the asymptote. Here, cosecant at pi also has an asymptote, trigonometric graph. Again, you're allowed to graph it and look at it and remember it. But again, because there's an asymptote there, that's why it doesn't exist. All right. In some cases, the left and the right sides are both increasing without bound or both decreasing without bound. Look at the example to the right. Both sides are both going in the same direction. Though the limit technically does not exist, we can also describe the limit as, in this case, approaching infinity. So the answer is actually infinity in terms of that. Though you could also say it doesn't exist because it's impossible to approach infinity. So if I look here in terms of as it's approaching, now a negative exponent, if you looked at the graph here, why not type it in? I'll show it to you. Negative 2x to the negative 4. So what I want you to see is both ends, both around 0, to the left and to the right, both are going down. So you could say it doesn't exist at 0, or you could say that both sides are approaching negative infinity. Here, for 1 over 3x squared, why not look at the graph? So 1 over 3x squared. Notice both the left and the right are both going to infinity. So we could write the answer as it doesn't exist, this limit, or it's going to infinity. Both are accurate. All right. There's your lesson, your introduction to limits. This is going to be the next one. So your homework is the next page right here. And there'll be a separate video on that. All right, Mr. G Math over and out. Until next time. Thank you for your patience as we introduce limits to you and open up a whole new world called calculus. Mr. G Math over.